You are welcome to Corrosive Online Tutorial, where complex topics are made easy for you to understand. In this short video, I just want to talk the difference between scalar and vector in more details. For example, in my last video, I talked about distance. It's an example of scalar quantity, and displacement is an example of a vector quantity. Okay? Now, let me try to throw more light. What is distance? What comes to your mind when you hear the word distance? Now, the word distance means that how far an object has traveled. Okay? The word distance, what comes to mind immediately is that how far an object has what? Has traveled. Or you can say the difference between 2 points. So if I have point A and the object moves from point A to point B, and if point A is 60 meter and point B is 100 meter, the difference between these 2 points is going to be 100 meter minus 60 meter, and that will give us 40 meter. So we can say that the distance between point A and point B is what? 40. So the object has traveled 40 meters. So when you hear the word distance, is talking about how far an object has traveled or the difference between 2 points. I hope that is understood. Now, let's say, for example, an object travels from point A to point B and back to point C. And let's say from point A to point B is 20 meters. And from point B to point C is 5 meters. Let's assume that. Now, the total distance covered by this object is going to be, the distance covered so far is going to be 20 plus 5, because from here to here you cover 20 meters. From here to here you cover 5. So the total distance is going to be what? 20 plus 5, and that will give us what? 25 meters. Now let's come to displacement. What is displacement? Displacement is a distance moved in a specified direction. So displacement is a distance with direction. And direction has to do with sign. Okay? And you remember your cardinal point. When you are going towards the positive y-axis, it is positive. If you are going to the south, the negative y-axis, it is negative. So here is negative. When you are going up, is what? Positive. If you are going towards the east, it is positive. That is the negative, a positive x-axis. And if you are going towards the west, it is what? Negative. So these are the various signs that show us the direction of what. And this place we can say, here is the what? The northeast. Here is the what? The southeast. Here is the what? The southwest. Here is the what? The northward. The northwest. So these are the various directions of an object, the possible direction of an object. So take note of that displacement always go with what? With sign. For example, let's say a man or a car or an object move from point A to point B, the same distance of 20 meters, and back to point C, the same distance of what? 5 meters. They ask, what is the displacement of the man? Now, when he's going towards the positive x-axis, it is positive. So you give the 20 positive. But when he's going back to the negative x-axis, it is what? Negative. So displacement is going to be 20 minus 5, and that will give us 15 meters. So you see the difference between displacement and distance. On one hand, the distance covered was 25. On the other hand, the displacement here was what? Was 5. I hope that is understood. Now, let's also look at this also. Let's take a look at this one. Now, if, for example, the same object move from point A to point B, here he used 10 meters, and from point B to point C, he also used 10 meters. And you are asked here that what is the distance covered by the man? Okay, the man moved from point A to point B 10 meters, from point B to point C 10 meters. So the distance covered by the man is going to be what? 10 plus what? 10. And that will give us what? 20 meter. But let's look at displacement. What happens? Now, if from A to B, it is 10, okay? And from B to C, it is also what? 10 meter. Now, what will be the displacement? Now, you can see that the displacement is a vector quantity, and the angle between the two vectors is 90 there. You can see it's 90 degrees. So to know the resultant displacement, we have to apply the resultant, or the resultant of displacement is going to be the hypotenuse of the right angle triangle. The hypotenuse of the right angle triangle will give us the resultant displacement of this object or body that moves from point A to point B and from point B to point what? Point C. And anytime you are dealing with a right angle triangle, you apply the Pythagoras theorem. And the Pythagoras theorem says the longest side, which is the hypotenuse square, is equal to the what? Adjacent square plus the what? Opposite square. So it's saying that if here to here is AC, it's saying AC square, which is the hypotenuse, is equal to the AB square plus the BC square. The BC square. Now, your AC square is R, which is the resultant of the what? Displacement. So you put R square. The AB is 100 square. The BC is what? 100 what? Square. Now, 10 square. And 10 square will give us 100. 10 square will give us what? 100. And when we add them, we get 200. Okay? We get 200. Now, R square is equals to 200. Now take the square root of both sides. When you do that, so R will now be what? You can break this is solid, you can break it down times 100. And this one will now give us 10 root 2. So the displacement will be what? 10 root 2 meters. Why in this case the displacement is just 20 meters. I hope that is understood. Now let's look at speed and velocity. Speed and velocity can be another example also. Vector and scalar. Now look at speed. Speed is a scalar quantity, while velocity is a vector quantity. The formula for speed is distance over time, and the formula for velocity is displacement over what? Time. The formula for velocity is displacement over time. Now, what comes to your mind when you hear the word speed? Speed talks about how fast an object has traveled. How fast. For example, a car moving at 50 meters per second and a car moving at 100 meters per second have different speed. The one with 100 meters per second have a higher speed than the one with 50 meters per second. Now, what does it mean, 50 meters per second? It means that in every second, the car will cover a distance of 50 meters. Every second, the car will cover a distance of 50 meters. So we can say in 3 seconds, the car must have covered 150 meters of distance. Then what does this statement mean, 100 meters per second? It means in every second, the car covers a distance of what? 100 meters. So in 5 seconds, the car must have covered 500 meters, because every second it covers 100 meters. That is what it means when you talk about the speed. So this 100 meters have a higher speed than this. So when you hear the word speed, it's how fast an object has what? Traveled. Now, velocity is just a speed with direction. For example, I can say a car traveling at 50 meters per second. A car traveling at 50 meters per second. This is an example of what? Speed. Where is the car going? I don't know. It was not indicated. But if I say that a car traveling at 50 meter per second northward. Northward. It means that the car is heading towards the north, towards the positive y-axis. So this is an example of what? Velocity, because it has a magnitude which is 50 and a direction which is what? Northward. I hope that is understood. Now the last thing I want to touch now is the average speed and average velocity. Average speed and average velocity. Now here you have your average speed. Here you have your average velocity. Average velocity. Now, what is average speed and what is average velocity? This is total distance over total time. Here will be displacement over total what? Time. For example, if a man move from point A to point B and back to point C, from point A to point B, it cover a distance of 20 meters. From point B to point C, it cover 10 meters. The time taken from point A to point B is 3 seconds, while the time taken from point B to point C is 2 seconds. So if you are given that now, what is the average speed of the man or the object? What is the average speed? So you write the formula: average speed is equals to total distance over total time. Now, the total distance from point A to point B is 20 meters. From point B to point C is 10 meters. Altogether will give us what? 20 plus 10 over the time from point A to point B is 3 seconds. The time from point B to point C is 2 seconds. So 2 plus 3, you get 5. So that will now give us 30 divided by what? 5, and that will give us 6 meter per second. So the average speed is 6 meter per second. Now let's look at the average velocity. Now the average velocity of the car will be different because of the sign. When you are going towards the positive x-axis, it is plus. When you are going towards the negative x-axis, it is what? Minus. So the average velocity will now be 20 minus 10. 20 minus 10 and over the total time. Here is 3 seconds going forward, and going backward is 2 seconds. That is over 5. So that will now give us 10 over 5, and that will give us 2 meters per second. So the average velocity is 2 meters per second, while the average speed is 6 meters per second. I hope you understood everything we have done today. So in my next video, I'm going to throw more light on different aspects of physics. Until then, bye for now.